Okay, so we've been talking about work energy theorem here for like over a week. So now we're going to be looking at a little lab that's basically just going to kind of confirm what we thought about the relationship between force, distance, and work, as well as how work can change the energy or the mechanical energy of something, okay, when work is done to it. So that's what we're going to be looking at here. It's a very, very simple lab, okay? You're going to be using a spring scale, like this one. Okay, so as you pull on it, it reads the different amounts of force. Well, it's supposed to read the different amounts of force on it. See, we ordered ones that are supposed to have newtons on them. The box shows a picture of a scale that has newtons on it. Inside the box is a scale with grams and ounces.
What a little lie.
And we called them. We're like, hey, you sent us the wrong scales. And we're like, no. They're like, no, we sent you the right things. We're like, you know, you sent us the right box. Unfortunately, the important thing is inside the box and it's wrong. Anyway, they wouldn't refund our money or give us the right ones. We never ordered from them again. Customer's always right. And we actually were right. Not only that, but we actually were right. But whatever. Customer service is a thing of the past. Anyway, okay? So you're going to be using these scales, but you're going to have to do a very small, very easy conversion. You'll have to divide whatever it reads on the scale in grams by 100. And then it will be in newtons, approximately. It'll do. Okay, it'll do for what we need. So that's what you will do. Okay, divide whatever number you have, and you'll have the force in newtons. So if you have 400 grams, it's 4 newtons. Okay, everybody good with that? All right. In your chart, okay, on your report there, you're going to need to pick several distances to stretch the rubber band to. Okay. I would say that you should probably not go more than 15 centimeters. I think if you do that, in fact, I think you'll be lucky to get it to stretch 15 centimeters. So what I would do is, rather than write these down, is once you have your setup, okay, I would pull the scale until it's at its maximum, and then record that distance, okay, and then pick some other distances that are smaller than that, kind of back to, incrementally back. Everybody follow there? Otherwise, you'll be like pulling and pulling and pulling, and then you'll be, oh, I maxed it out, and you'll have to go back and decide on some others. Okay, I would say just pull it to its maximum first, and then go back from there. Okay. Now, on the scale, you do need to make sure that it's zeroed. Okay. And what I mean by that is this little thing inside can be moved. Okay. And so you need to make sure that when there's no tension on it, that it's at 0. Okay, it's easy to move, but sometimes they get knocked around a little bit. Okay, you also need to make sure that you get a 2,000 gram scale. There's 2,000s and there's 500s in that box, and the 500s are just not going to get the job done. They're all labeled. Okay, just pick a box that says 2,000, and in case someone has put in the wrong scale, the 2,000s are all red and go up to 2,000. Okay, the 500s are green and obviously only go up to 500, so you need one of these. Okay. The other thing you're going to need is a rubber band. Now, the rubber band is going to go between the legs of 2 desks. Okay, so if you look at the desks kind of here, okay, you're going to want to put it between the feet of 2 desks so that they can be fairly close together. All you want is for initially the rubber band to be taut. Okay, not stretched, just taut, so that it's not hanging loose. Okay, just taut. Right? And you're going to put the ruler underneath that. Okay, so you're going to put a meter stick, which I haven't got out here yet, a meter stick on the floor, okay, and the 0 needs to be right in the middle of the 2 pieces of rubber band. Okay? Then you're going to hook the scale onto both pieces of rubber band and pull during the experiment, both sides. Okay? Crucial that you do that. Okay? Both sides. You're just going to pull that back to the various distances, and you're going to measure the force. Okay? So I'll say that again. We're picking the distances, and the force will respond to those distances. Okay. Now, a couple of things you need to be mindful of, or make sure that you control throughout the experiment. Get somebody caught that. Okay. The rubber band must remain the same throughout the entire experiment, including its initial condition. That means that 2 members of your group Their only job is to sit in the desks and make sure the desks don't move. Okay? Because if you start pulling on this rubber band and there's nobody in the desks will move. Okay? So there needs to be weight in the desk. You don't need to make this a big deal about who's biggest and who's not and whatever. Any person will do. Okay? It just needs to be a few pounds in the seat. Okay? And it'll be enough to keep the seat from moving so no one gets their feelings hurt. Okay? You laugh. It happens. I only bring it up because it happens. Okay? I wouldn't bring it up unless there were people out there cruel and stupid who do things like that. Okay? All right. So, just enough that it's taught. Okay? Make sure the desks don't move. The initial condition of the rubber band. If for some reason these rubber bands, if it breaks in the middle of the experiment, what do you need to do? Get a new one and start over. Yeah. Okay? They should all be the same, but we can't guarantee that. Okay, so if it does break in the middle, okay, then you need to get a new one. All right, they shouldn't, okay, but if they do, okay, be aware of that. All right. Now, for our hypothesis, okay, the if part of our hypothesis should be a definition of work. Okay, we know what that is, okay, because we've said it 100 times and even said it twice already this morning. Okay, the and part, as always, needs to describe the experiment. In the then part, I'm going to want you to say a couple of things. Okay. In the then part. Oh, look, even part of the hypothesis is right there. Okay. In the then part of the hypothesis, what I'm going to want you to talk about is what's going on when you are stretching the rubber band. And here's what I mean. Not the rubber band is stretched. Okay. Right, you're not going to get a very good mark on your hypothesis. Okay, what I'm looking for here is what are you doing? What is happening? Especially focused on changes in energy. Okay, what is going on in terms of transfers, changes, okay, things like that that are going on as a result of you pulling on the elastic band. Okay, so the then part is actually going to talk about what's happening to the rubber band. Okay, as a result of what you're doing in terms of energy changes. Okay, not in terms of it stretches and gets longer. Obviously that happens. Okay, what happens in terms of energy changes to the rubber band? Okay. Now, when you have collected your data, that is, you filled in this chart, okay, with your distances and your forces, okay, and obviously a distance of 0 is going to require a force of 0. You do want that in your data table, okay. Once you've got that filled in, then you need to open a Google Sheet. I didn't include one this time. You can just make one, okay. You need to open a Google Sheet and you need to build a distance versus force graph, okay. A distance versus force graph. Remember, we're not only looking at this relationship, work being a change in energy, but we're also looking at this relationship. And we're hoping to get something that looks like this. And by hoping, I mean if you don't, you broke the laws of physics and did something really, really wrong. Okay? That's what your graph should look like. Okay? Now, in terms of this graph, okay, we can use this graph to calculate something, okay, that maybe isn't on the graph, but is maybe part of this, okay? That's what the analysis is all about, okay? So, in the analysis and interpretation, okay, it says we can calculate the area beneath the line on a force distance graph, okay, by simply finding the area of a triangle, okay? Area equals 1/2 the base times the height. Now, what if your triangle doesn't start at 0, 0? What if you have a y-intercept? Then you got a rectangle underneath as well. You guys know how to do that, okay? It's not a big deal. You can handle that, okay? So you're going to calculate the area underneath, okay? And when you have that, think about what you're doing. Okay? When you calculate that area, what things are you multiplying together? Okay? And what is that going to give you? That's what you need to answer in question number 2. And I do not want just a one-word answer here. Okay? Question number 2 says, what does the area under a force distance graph represent? how do you know? The how do you know is just as important as what does it represent. Okay, make sure you're explaining. Okay, you might even want to talk about some of this math, okay, that you did in question number 1, okay, and why that is what it is. Okay, is that pretty straightforward? Okay, without me giving away the answer. All right. Now, conclusion, same as always, copy paste your hypothesis and then explain. Okay, did the energy conversions that you observed happen? Okay, and how do you know they happened? Was there something in the math that you did here, okay, that confirms there was an energy change for the rubber band? Okay, were there some practical or common sense things that would say, yes, there was, energy stored in the rubber band or whatever? Okay, whatever you think goes on in the lab. Okay, things of that nature. Okay, and then for your evaluation, sources of error. Okay, suggest improvements. So 2 sources, and then we'll talk about the class discussions after I hand back the lab reports next week. So this is going to be due for you. I think I made it due on the 16th. Okay, because I want to have it back to you before your unit exam on the 18th. All right, so yeah, by the way, that's when that is. I told you that last week. I will be putting up the unit exam review probably today, so you can start having a look at that. All right, are there any questions on this? Okay, so the procedure shouldn't take you very long. Okay, I'm just going to grab the meter stick so you can get started on that. I need the rubber bands back. Okay, so when you're done, if you can put the rubber bands back in the bag, which will be over by the scales. Okay, that would be great because I still have an afternoon class that needs to do this, and I'm starting to get low. This I thought bottomless bag is now nearing the bottom, so okay, make sure that those get back in there. Okay, if you have questions while you're doing it, just let me know. Okay.